Hello, welcome to our paper 11 session, the first of 8 where we expect to cover the entire syllabus. The topic obviously is MDC and I am your tutor. My name is Hannington. You're most welcome in this session. Alright, I believe you have the class notes already. This is our part 2 of cost estimations and cost behavior. You already have part 1, which was all about the introduction of the topic, an overview about some of the approaches used to predict costs and analyze costs according to their behaviors, that is variable as well as their fixed elements. Now in this part, of course, I'll go through the least squares technique. As you can see on your screen, I'll go through the least squares techniques. Then I'll try to also go through some worked examples about each of the methods. So pay attention to what I'll go through. Then I'll also refer you to the revision kit to try out some past paper questions. Okay, let us try to go through the least squares technique. Now, the least squares technique, as I told you, is that whenever there is a relationship, that is a cause and effect relationship between the variables, that is the dependent variable and the independent variable. So if there is that relationship in the data, then the linear function is the appropriate, and what we can use, that is a statistical technique known as the least squares method. Now this technique can be used to establish values for coefficients of A and B. Remember, I told you that A, that represents a fixed cost, then B, that is your variable cost per unit in that linear cost function. So we have our equation, or what we call the linear cost function, which is y equaling to A plus bx, and A is the total cost, which is the dependent variable, and the x, that is the aggregate measure of activity, and that is your independent variable. Now we need to know what is a cost function. What is a cost? What is a cost function? Now, a cost function, we can define a cost function as simply a regression equation that describes the relationship between a dependent variable and one or more independent variable. A regression equation that describes the relationship between a dependent and one or more independent variable, that's a cost function. Then from a cost function, another key term is a dependent variable. You also need to know what a dependent variable is. Now a dependent variable, that is simply a cost or any other variable that changes when an independent variable is varied. Take an example of maintenance costs and machine hours. So in that case, maintenance cost is the dependent variable and the machine hours is your independent variable. Now what is an independent variable? An independent variable, that is simply any variable that can be volume, it can be machine hours, it can be labor hours, or any other cost driver that affects the value of the dependent variable, such as costs. So you need to know these key terms: cost function, dependent variable, and then the independent variable. Your A is a constant, and that is always a fixed amount. Then B is also a constant, that is your variable cost per unit, and that is the coefficient of x, meaning that I just need to get the value of x, I multiply that value by the value of b to come up with my variable costs. Now, if y equals to a plus bx, then b equals to n summation xy minus summation x summation y over n summation x squared minus summation x in brackets, then squared. Then UL equal to the summation of y over n minus b summation x over n. Of course, we are going to look at a worked example, and then we see how we can use this formula to come up with b and b to come up with a cost function that can be used to predict costs in future. Now, in this formula, you will see that we have n because the other variables have been explained, but now we have n, and n is the number of the pair of data for x and y. So you have to count the pair of data to find out the n value. Then from there, of course, we have steps that are always involved in estimating cost functions. We basically have 6 major steps, and the first step always is to select the dependent variable y, that is the cost variable always, which we need to predict. Then after selecting your dependent variable, the next step is always to select the potential cost drivers. Select the potential cost driver, and of course these potential cost drivers, those are your independent variable. Then collect data on this dependent variable and the cost drivers. Then plot the observations on the graph, that is the cost data on one axis and the dependent variable and the cost drivers on the other axis. Then estimate the cost function. Estimate your cost function. That is y equaling to a plus b x. Y equaling to a plus b plus bx. Y equaling to a plus bx, where y is your dependent variable, a, that is a fixed amount, then b is the coefficient of x, and it's always a constant amount or a constant value, and x is your independent variable. Then after coming up with your cost function, the next step is always to test the reliability of the cost function. Test the reliability of the cost function. Of course, we are going to look at tests of reliability in this session as well. Test of reliability. Now, when it comes to test of reliability, these are statistical and graphical methods which we can use to test the strength of the relationship between the variable and the independent variable. Methods and some other techniques which we can use to test that strength of the relationship between the independent and the dependent variable. That is test of reliability. So here we are going to be looking at concepts like correlation. And remember, correlation is all about the extent to which the values of y can be predicted from any given value for x using the values of a and b obtained from the linear regression analysis. There can be a high degree of correlation as well as a low degree of correlation. So we are going to see how we can really use the different techniques to test that strength of the relationship between our variables, that is independent as well as the dependent variable. Now, various techniques of reliability can be applied to see the strength The most simplistic approach is to plot the data for each potential cost driver and examine the distances from the straight line from a visual fit, and that is always the graphical method. So we can use the graphical method to test the relationship between our two variables, that is the dependent and the independent, and the dependent variable, or we can also use the least squares equation. The least squares equation. Now, a most sophisticated approach is to compute the coefficient of variation. To compute the coefficient of variation. Now, the coefficient of variation, that is simply the square of the correlation coefficient. Square of the correlation coefficient. Meaning that this should be r squared. It should be r squared. And that r squared represents the coefficient of variation. Now, here we have some key concepts which we need to be familiar with. That is coefficient of determination. And coefficient of determination, that is always about the measure that shows how much of the variation in the dependent variable is caused by variations in the independent variable. So there is always a variation in the dependent variable. So this coefficient of determination shows you the measure of how much the variation in the dependent variable is caused by variations in the independent variable, and how much random variations and other independent variables, meaning that the changes in the dependent variable can be caused by variations in the independent variable, and at the same time those changes in the dependent variable can be caused by some other random variations in the other independent variables. Then you also have what we call the coefficient of variation, and the coefficient of variation, that is simply the square of the correlation coefficient, measuring the percentage variation in the dependent variable that is explained by the independent variable. So by a correlation coefficient, we can determine in percentage terms. We can determine in percentage terms the causes of the variations in the dependent variable and independent variable, as well as the percentage change in variations as a result of changes in other independent variables. Then correlation coefficient, that is simply the strength of the linear relationship between two variables. So I look at my dependent variable and the independent variable, then I determine that correlation coefficient. How strong, or how can we reliably measure the values of the dependent variable by using information about our independent variable. So that is the least squares method. So we have covered the engineering method already, the high-low method, the scatter graph approach. Now this is our least squares method. Then we also covered the inspection of the accounts method. So you have to master how to use all these techniques. Now in our next session, of course, I'm going to do some worked examples, and we see how we can use all these approaches to estimate and predict costs. Our first approach, we are going to first have a look at the inspection of the accounts method, and we see how we can apply the inspection of the accounts method to predict costs. Inspection of the accounts method. Remember, I told you that under the inspection of the accounts method, you have to get the cost accounts, that is your cost data, identify which costs are variable, and identify which costs are fixed. For the variable costs, determine a single average unit cost, then come up with a single figure for the fixed amounts, then formulate your cost function which you can use to predict future costs. Remember, I told you that this method cannot be used to analyze semi-variable cost into their fixed and variable elements, meaning that whenever we have semi-variable cost, there is always some subjectivity or some arbitrary assumptions on how to treat these costs, because it's just always a matter of agreement between the departmental managers and the accountant on whether to treat such costs as variable or as fixed costs. Now we have our illustration here. This same illustration, you have it in your notes, so you can go to where you have inspection of accounts method. Now the following cost information has been obtained from the latest monthly accounts for an output level of 10,000 units. So we have an output level of 10,000 units for a cost center. You have direct materials 100,000. Now this direct materials is incurred for a total of 10,000 units. You have 140,000 units. That is direct labor. Then we have indirect labor. We have depreciation. Then we also have repairs and maintenance. But as you can see, this is a semi-variable cost where a half is fixed and the other half is variable. Required: examine each item of expense and analyze expenses into their variable and non-variable elements. Examine each item of expense and analyze the expense into their variable and non-variable elements. Direct materials, this is a variable element, so it's a variable cost. Direct labor is also a direct cost or a variable element. Now indirect labor, this is a non-variable element because it is indirect. We cannot specifically trace this to specific units of a product. Depreciation, this is a non-variable element. Repairs and maintenance, this is the semi-variable, but we know that half, that is 5,000, is variable and the other half is fixed. Now this is our suggested solution. Repairs and maintenance have been classified as a semi-variable cost consisting of a variable element of shillings 0.5 per unit. Remember, it is 10,000 cash and our output is also 10,000, meaning that the cost per unit is 1, but out of that cost per unit of shillings 1, 0.5 per unit is variable plus shillings 5,000 non-variable cost. So 5,000 is variable, 5,000 is non-variable. And for the variable cost or the variable cost element, we have to determine the variable cost per unit, and in this case that is 0.5. A check on the total cost calculation indicates that the estimate of the unit variable cost of shillings 24.5, now this is the summation of all the unit variable cost, will give a total variable cost of shillings 245,000. So that is your variable cost out of the total at an output level of 10,000 units. The non-variable cost of shillings 50,000 are added to this to produce an estimated total cost of shillings 295. This is the same total of all the costs you have in the question, as you can see. But we have separated that into the variable and the non-variable component. So the variable component is 245,000 and the non-variable component is 50,000. Now we have our cost function, that is y equaling to 50,000, that is the fixed component, plus the 24.50, that is your b, the coefficient of x. So this cost function can be used to estimate total costs at other output levels. So that is the inspection of the accounts method. Always go through the cost data, identify which costs are variable and which costs are fixed. Come up with your cost function, which can be used to predict future costs. That is the inspection of the accounts method. Now from there, I'll take you to the high-low method. We see how we can use this high-low method. How we can use the high-low method to predict costs. Now, a department in a large organization wishes to develop a method of predicting its total cost in a period. The following data have been recorded. So we have different months, we have our activity level, as well as the costs. The total cost model for a period could be represented by what equation? Now, as I told you that in the high-low method, always go through the data. This is our data about costs and the activity level. I told you that always select the cost at the highest activity level. Now, what is our highest activity level in this case? Our highest activity level is in February, where we have 300 units. And the cost at that highest activity level is 29,600. The lowest activity level, that is in May, and we have 1,500 units. That's for the activity level, lowest. And then we also have 80,000 shillings. That is our cost. So we start by getting our variable cost per unit, and that is always getting the difference between the cost at the highest activity level, that is 29,600 and 28,000. So you get the difference in these two over the difference in the units, that is at high activity level and the lowest activity level. So you get the change in cost as well as the change in units. Let me take you to the solution and see how we use this method. So we have our total cost at the highest activity level, that is 29,600. Then the total cost at the lowest activity level, 28,000. Then units at the highest activity level, that is 2,300, and then 1,500. So by getting the change in the cost over the change in the units, you come up with a variable cost of shillings 2. So that should always be your starting point. The first step, always you have to calculate that variable cost per unit. Remember, this is a constant. Then after getting the variable cost per unit, it simply means that I can get my fixed costs at any activity level. Remember, fixed costs, these are constant costs. So you expect the same cost at any activity level. Now, taking my highest activity level, where the total cost is 29,600, I minus my variable cost from the total cost to come up with the fixed cost portion. So meaning that the 29,600 is a mixed cost, but it has a variable cost part as well as a fixed cost element. So out of the 29,600, 25,000 is a fixed cost. So the total costs equals to 25,000, that is your fixed component, plus the variable cost per unit, x, that is also a constant, and x, which is your independent variable, and that can be volume of activity in the units. So that is the high-low method. Then from the high-low method, let me take you to the least squares method. How to use the least squares method. Now, under the least squares method or under linear regression analysis, I'll start with a simple regression analysis. Now, a simple regression analysis, this is simply regression equation analysis that only contains one independent variable. So we are going to first make an assumption that we have one independent variable in our analysis, and that is simple regression. So simple regression, that is where you have one independent variable. Now we have this information about production volumes as well as total costs, production volumes as well as total costs. So production volume is our independent variable, then cost is our dependent variable. What are we required to do? Analyze the total costs into fixed and variable costs. Analyze the total cost into fixed and variable costs based on the data given utilizing the least squares method. Utilizing the least squares method. Okay, let's see how we can come up with our solution. So I have this information. We have our production volume. Now production volume, that is the independent variable. So we can name this x. Now this total